Hey guys, a couple more questions by request. This is homework 5.4, the last two questions, 13 and 14. So here's number 13. It says lengths of lumber machine cuts are normally distributed, mean of 94 inches, standard deviation of zero point 0.4. What's the probability that a randomly selected board cut by the machine has length greater than 94.16? Okay, so typical question for normal distributions. Going to go to the normal distribution, input my average, which was 94, my standard deviation of zero point 0.4, and this is a single board, so I can just leave it as zero point 0.4. I'm checking the data value of 94.16, and I want to know the probability that's bigger. So I'm looking for bigger, the greater than symbol. That's 0.344578. To the nearest 4 would be 0.3446. Check that. Okay. And then now second question, if I take a sample of 41, repeat the same question. So the only thing that's going to change here is the standard deviation. That's going to be equal to 0 0.4, but divided by the square root of 41. And then now the probability drops significantly. And here it's 0.0052 to the nearest 4 decimal places. Okay. And then the last question, 14. Let me zoom out a little bit. Okay, so it's about 79% of all female heart transplant patients survive the last at least 3 years, sorry. 90 female heart transplant patients are randomly selected. What is the probability that the sample proportion surviving for at least 3 years will be less than 71%? Assuming you have normal distribution, the mean is equal to the population proportion. The standard deviation is equal to square root of PQ over N. Okay, so again, kind of similar question. There's a little bit extra here we have to do, which is the standard deviation for proportions, but they give us the formula right there. Let's start by inputting our average though. Average is 79%, right? That's the first statement that's given, 0.79. So I'm gonna put 0.79. And then for the sigma, I want the square root of PQ over N. Let me do this in a separate calculator so you can see exactly what's going on here. So here, P is 0.71. That's the proportion of, oh, I'm sorry, 0.79. The probability of success, right? Or success meaning survival. Then Q would be equal to 1 minus that. So in this case, 0.21, right? 1 minus 0.79. And then N here is, what was my N? N is sample size. Where was it? Uh, I saw it a moment ago. 90 here, 90. Yeah, 90 female heart transplant patients with 90. So now what I want is the square root of PQ divided by N. Or if you prefer, you can write it as the actual values. You can, if you define your variables once, then you can just type them in like this, as long as you don't repeat the same letters somewhere else. So, but you can also just do it like this if you want to. Just type it in. You get the same thing either way. Okay, so 0.0429, 0.0429340. That should be enough digits. Okay. So that's the standard deviation here. And then now I'm looking for what is the probability sample proportion surviving at least 3 years. So I'm looking for 71%. Will be less than 71%. So 0.71. The 3 year part, that's not something that you have to input because um that's just the number of years that you survive, but that's nothing to do with the probability statement. Or it has something to do with the probability statement, but that's just the number of years that's common to both, right? So that's not changing, and that's not something that would go anywhere in our calculation. It's not the mean, so it's not the standard deviation, and it's not the data value. Okay, so what are we looking for? We're looking for the probability that at least that many survive. So it's will be less than 71%. So we're looking for less than the value that's 0.0312. 0.0312. Okay, is that it? Okay, that's it. All right. So yeah.